The National Electrical Code, or NEC, does not specify a specific resistance value for grounding electrodes beyond the requirement for a driven ground rod to have a resistance of 25 ohms or less to earth, as detailed in NEC 250.52 A4. However, local electrical inspectors may have their own requirements for grounding electrode resistance, and these requirements may vary from the NEC. These requirements can often be found in local building codes or ordinances. It is important to be aware of both the NEC requirements and any local regulations in your specific area. The Institute of Electrical and Electronics Engineers, or IEEE, Standard 142-2007, titled IEEE Recommended Practice for Grounding of Industrial and Commercial Power Systems, recommends a grounding electrode resistance of 5 ohms or less for most applications. This standard, however, is not mandatory and may not be adopted by local authorities. It serves as a recommended practice to enhance safety and performance in grounding systems. After the installation of multiple grounding rods, the NEC does not specify a resistance value for grounding electrodes. The code focuses on ensuring a low impedance path to ground. Local electrical inspectors may have specific requirements in these cases, and it is always advisable to check with the authority having jurisdiction, or OJ, for the applicable regulations in your specific area. Grounding is a critical aspect of electrical safety, designed to protect people and equipment from electrical shock and damage. The grounding system provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices such as circuit breakers and fuses to operate and clear the fault. A well-designed grounding system minimizes the risk of electrical hazards and ensures the safe operation of electrical equipment. The NEC provides minimum requirements for grounding systems, but it is important to understand that these are just the baseline standards. In many cases, exceeding these minimum requirements can improve the overall performance and safety of the electrical system. Local jurisdictions may have additional requirements based on specific local conditions or concerns. Grounding electrodes are typically made of copper or other conductive materials and are buried in the earth to provide a connection to ground. Common types of grounding electrodes include ground rods, ground plates, and underground metallic water pipes. The size and type of grounding electrode required will depend on the size and type of electrical system being grounded, as well as local soil conditions. The resistance of the grounding electrode to earth is an important factor in determining the effectiveness of the grounding system. A low resistance to earth ensures that fault currents can flow quickly and easily to ground, allowing overcurrent protection devices to operate and clear the fault. The NEC requires that a single driven ground rod have a resistance of 25 ohms or less to earth. If a single ground rod does not meet this requirement, the NEC requires that an additional grounding electrode be installed. This can be another ground rod, a ground plate, or another type of grounding electrode. The NEC does not specify a specific resistance value for the combined grounding electrodes after the installation of multiple grounding electrodes. The focus is on ensuring a low impedance path to ground. However, as mentioned earlier, local jurisdictions may have specific requirements for the combined resistance of grounding electrodes. Measuring the resistance of a grounding electrode to earth can be done using a ground resistance tester. This device injects a current into the earth and measures the voltage drop to determine the resistance. It is important to follow the manufacturer's instructions when using a ground resistance tester. Regular testing of grounding electrode resistance is recommended to ensure that the grounding system is functioning properly. Changes in soil conditions such as moisture content and temperature can affect the resistance of the grounding electrode. In addition to grounding electrodes, the grounding system also includes the grounding electrode conductor, which connects the grounding electrode to the electrical system. The grounding electrode conductor must be sized properly to carry the available fault current. The NEC provides specific requirements for the size of the grounding electrode conductor based on the size of the electrical system. Bonding is another important aspect of the grounding system. Bonding involves connecting all metallic parts of the electrical system together to create a common ground potential. This includes metallic conduits, enclosures, and equipment frames. Bonding helps to prevent voltage differences between metallic parts, which can create a shock hazard. The NEC provides specific requirements for bonding electrical systems. Equipment grounding conductors, or EGs, are used to connect the metallic part of equipment to the grounding system. The EGC provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices to operate and clear the fault. The NEC provides specific requirements for the size and type of EGC. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing in the circuit and compare it to the current returning. If there is a difference of more than a few milliamperes, the GFCI will trip and interrupt the circuit. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. SPD divert the surge current to ground, protecting sensitive electronic equipment from damage. The NEC provides specific requirements for the installation of SPD. Maintaining a safe and effective grounding system is an ongoing process. Regular inspections and testing are essential to ensure that the grounding system is functioning properly. Any problems that are identified should be corrected promptly. Working on electrical systems can be dangerous. It is important to follow all safety precautions when working on electrical systems, including wearing appropriate personal protective equipment, or PPE, and energizing circuits before working on them. Only qualified and licensed electricians should perform electrical work. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC and other electrical codes in a specific area. The AHA may be a local building inspector, a state electrical inspector, or another official. It is important to check with the AHA to determine the specific electrical codes and regulations that are in effect in your area. Understanding grounding electrode resistance requirements is crucial for ensuring electrical safety. The NEC provides minimum requirements, but local jurisdictions may have additional requirements. Consulting with the AHA and following industry best practices, such as those recommended by IEEE, can help to ensure that the grounding system is safe and effective. Always prioritize safety when working with electricity. Remember to de-energize circuits before working on them and to use appropriate personal protective equipment. If you are not qualified to perform electrical work, hire a licensed electrician. Proper grounding is not just about meeting code requirements, it is about protecting people and equipment from electrical hazards. By understanding grounding principles and following best practices, you can help to ensure a safe and reliable electrical system. In summary, firstly, the NEC sets a minimum resistance requirement of 25 ohms for a single driven ground rod. Secondly, local inspectors may have stricter requirements. Thirdly, IEEE recommends 5 ohms or less. And fourthly, always consult your local AHA for specific regulations. These regulations might be in addition to what the NEC requires. Always adhere to the strictest requirement, and be sure to get a permit to do any electrical work or hire a licensed electrician to do the work for you. They will know all of the local codes and ensure everything is up to par with the requirements of your local jurisdiction. When in doubt, it is always best to over-engineer the situation so that there are no mistakes. Safety is number one, and grounding is an integral part of safety. Remember that grounding rods must be 8 feet long and driven all the way into the ground. The grounding wire that runs to it must be appropriately sized and securely fastened to the grounding rod. If you have any doubts about your ability to install a grounding rod safely and properly, consult a licensed electrician. Do not attempt to do electrical work if you are not qualified to do so. Electricity is dangerous and can cause serious injury or death. Only qualified personnel should perform electrical work. Also, remember to call 811 before you dig to ensure that you do not hit any underground utilities. Hitting an underground utility can be dangerous and can cause service interruptions. Always be safe when working around electricity and remember to call 811 before you dig. Also be sure to measure the resistance with a ground resistance meter to be certain of compliance.